Enriching the Parametric Vocabulary of Urban Landscapes, a framework for computer-aided performance evaluation of sustainable development design models by Hatzav, Yoffe, Pnina, Plaut, Fried, and Yasha J. Grobman from the Technion. In the urban millennium, 54% of humans live in cities with a projected increase of 2.5 billion urban dwellers by 2050. The ongoing urbanization and development process increased humanity's ecological footprint to exceed planet Earth's carrying capacity by 20%, consequently degrading habitats and endangering ecosystem services vital for livable environments, human quality of life, and well-being. Sustainable development of cities, which enhances and regenerates urban environments, is considered one of humanity's greatest challenges and should therefore be central to designing architecture and urban systems. 3 decades passed since the adoption of sustainability rating systems by the AEC industry as standard methods for sustainable development evaluation. Despite sustainability frameworks' abundance, performance evaluation in landscape architecture still lacks comparable data on social and environmental criteria, as well as on extensive evidence-based research compared to other disciplines. This lack stresses the importance of generating empirical-based evidence and performance documentation to support sustainability frameworks and to guide landscape design and decision-making. Recent advancements in the field of data science and smart cities pose new opportunities for measuring the performance of urban landscape. Available tools and methods utilize directed, automated, and sensor data like remote sensing, wireless networks, and cell geolocation data to inform urban planning and design analysis. Quantitative data of the built and natural environments can be manipulated using computation methods to measure new facets of sustainability. Existing research for advancing the evaluation frontiers of urban analysis couples different modeling tools into existing GIS and BIM platforms by creating fully quantitative evaluation workflows in a neighborhood scale and city scale. Nevertheless, there is a lack of quantitative evaluation frameworks for sustainability evaluation of landscape development. And this is where we come in. Existing sustainability rating systems are manually and generate a numeric score. Our proposed model uses computer-aided method to add composition and special metrics to the evaluation process. The result is a special enriched evaluation of a sustainability credit. These special metrics enrich the scientific model and are an indication for the design ecological performance. In this research project, we chose 3 key sustainability indicators for landscape performance, all measure regulating ecosystem services. We are discussing the optimized biomass evaluation credit based on the CITES rating systems, CITES V2 rating system for landscape development. And optimized biomass is the density of plant layer covering the ground. This is what we're measuring. Biomass measurement is important because it can indicate ecological attributes of the measured area. The composition and configuration principles we are using are based on landscape ecologies, which are established research field in landscape for the past 3 decades. In our model, we compare existing vegetation condition to proposed design conditions. And it's made of 3 steps. First of all, there is data preparation, then there's calculation, and then there's the analysis of the results. The analysis is an in-model representation. For this case study, we use 2 demonstration landscape development projects. One is a small park and one is a neighborhood. We took the design's CAD model and then we streamlined them into the custom designed Grasshopper calculator and then represented it back into the model. And this is the result. What we see here is the representation of one of the metrics, spatial metrics we added in the measurements, which is the MPI. MPI is mean proximity index, and it represents connectivity and fragmentation of an ecology. the new thing, or what we didn't know before, what we are adding here is a tool that can predict or give an indication about the ecological performance of the vegetation design. It can also inform us about diversity of the design in terms of planting schemes and spaces, etc. In terms of limitation of our research, we encountered a slow process time of our code. We encountered that small designs generate coarser results, and that the metrics work best on a neighborhood scale. And therefore we are fitting the right kind of metrics for the right kind of design scale. In terms of contribution, this method provides an indication to the design ecological performance. And this is a critical indication, quantitative indication in terms of sustainability, sustainable development of city environments. We are also advancing sustainability rating system by contributing additional comparable metrics of projects. And we are reducing the expert dependency using computation, and therefore we are lowering the entry level for sustainability evaluation for smaller or more common projects. Our future research includes extending key indicator development. We're currently looking into runoff management and microclimate heat island mitigation. And we are going to conduct validation experiments in collaboration with the municipality of Jerusalem. This is the opportunity to extend our invitation for international collaborations with cities across Europe and across the world. So we encourage you to contact us if this is of your interest. Thank you very much.